Before going into details of UPS components, we need to understand power semiconductors. Okay, the foundation of modern UPS system. Foundation you should understanding how diodes, thyristors and IGBTs work together to create reliable, efficient power conversion. How we are converting power? From raw AC to DC, we charge the battery, and again from that DC we are converting into pure sinusoidal controlled power, which does not have any impurities which are in the raw power. Okay, we are creating our own sinusoidal wave, own power. So by using these diodes, thyristors and IGBTs, so we need to understand the basic principles of these three things first. Okay, first is diode, the foundation of power conversion, the one-way valve. Okay, one-way valve, like water footwall of the motor. It will allow water to flow only upwards, downwards it will not allow. It is like this mechanism, closing and opening. The same way this diode acts. It will open, it's only one-way valve, in one direction only. Okay, visual structure, this is a symbol, diode, anode and cathode, positive side and negative side. Then p-n junction. Now exactly how it works, that we will see. How it works? Forward bias, conducting. Forward bias means in the direction of arrow, always remember. Okay, anode more positive than cathode. This is anode, p type, it's more positive than cathode. Then what happens exactly? Current flows freely, voltage drop. See how much voltage you need to apply to conduct this diode. It's a 0.7 volt, approximately 0.7 volt. After that, this diode will conduct. Acts like closed switch. Reverse bias. Cathode more positive than anode. Current completely blocked. If you apply the positive from this side and negative this side, it will not conduct. Opposite side, current will not flow. Current always flows from positive to negative. Okay, so this diode, it will act as an open switch. Now exactly how it happens, that I will explain here. Okay, we will just zoom in this diagram so that you will understand it better. See, these are empty holes, okay, and these are negative electrons. Now if you add more holes from this side, okay, and at the same time from this side also electrons will be applied, then what will happen? The strength of these holes will increase, and this is a barrier. This is very small barrier, okay, negative holes, and this is called depletion layer. So in short, it is a resistance of that particular diode, okay, resistance to flow of electrons. Now if you increase the force, the voltage more than 0.7 volt, till 0.7 volt it will not conduct. Then these positrons or positive ions will become more powerful and it will penetrate through this depletion layer. Then you have electrons this side, then electrons will go to meet holes and our current flow will be established. Now in reverse bias, what happens? See, this direction is what? This is reverse bias and this is forward bias. So forward bias we have seen how it works. Now in reverse bias, here more positrons, here more electrons. What will happen? No, it will not try to cross this junction. No, it will increase rather. Okay, negatives, this is a negative, what do you call it, depletion layer. It will increase, depletion layer will increase. Here again positrons, if possible, if it penetrates through, it will, this region, negative region will increase, this positive region will increase, and there will not be any current flow in reverse bias, no current flow. In forward bias, there will be current flow. You understood it, right? Simple. See here, okay, in pictorial diagram, forward bias is shown. See, positive is connected this side, so positive becomes more, and this depletion layer will be penetrated, and here this side negative, then this depletion layer will be penetrated. So current flow will get established. Depletion layer at 0.7 volt will be penetrated at 0.7 volt, and then current will establish its path. Now there are limitations. What are limitations? No control, it's automatic. Here we don't have any control when to switch on, when to switch off. No, once 0.7 volt is applied, it will conduct by its own. So conducts whenever voltage phase pushes forward. Okay, cannot control when it starts or stops, cannot regulate output voltage. No, it cannot regulate also. Where used in UPS? Simple rectifier bridges, freewheeling diodes, protection, and battery isolation circuits. Here these things are used. So these are the limitations and these are the usage of these diodes. Okay.